In this video, we will be looking at common factoring. But before we look at that and understand what it is, we're going to do a little warm-up where we expand an expression that we would see in grade 9. So if we look at 2x and then in brackets 4x plus 3, we know that if we want to get rid of the brackets, we just have to multiply the 2x into both terms. And that way the brackets will disappear. So 2x times 4x means I would do 2 times 4, which is 8, and x times x, which is x squared. And then 2x times 3, 2 times 3 is 6, and then the x has no one to get multiplied by, so it just stays there. Now, what we did here is we expanded. But for common factoring, or factoring in general, we are going in the opposite direction. So now we're going to take this expanded expression and try to bring back the brackets. And to get started with this idea of factoring, we're going to do a little fill in the blanks warm up based on our knowledge of distribution. So in my first example, I'm giving you the expanded form, which is 8x squared plus 4x, and I'm giving you the bracket 2x plus 1. I want to figure out the monomial, or the single term that would go out in front, so that when I multiply it in, I get that expanded form. So I know in my first multiplication I would do something times 2x to get that 8x squared. So when I think about it, well, 4 times 2 is 8, and then x times x is x squared. So I would get the 8x squared there. And then just to double check, I'm going to do 4x times 1, and that's 4x, so this works. Okay, let's try the next one. 6y squared minus 4y is going to equal something times 3y minus 2. So I'm going to start with the first one. I know something times 3y should give me that 6y squared. Well, 3 times 2 is 6, and y times y would give me y squared. And then just to double check, 2y times negative 2 is negative 4y, so that works. So in this example, or these two examples, I gave you the bracket, but we had to figure out that term in front. And the next one, I'm going to give you the term in front, and we have to figure out the leftover bracket. So 28x squared plus 8x equals 4x times a bracket. Because my starting expression started with 2 terms, my bracket should also have 2 terms. So I know the first thing I would do is 4x times something to give me 28x squared. Now, if you're not great with your multiplication and you're struggling to figure out 4 times what gives us 28, not a big deal. The opposite of multiplication is division. So if I just divide 28x squared by 4x, I should get the term that I should put in the bracket. So 28 divided by 4 is 7. And 4 times 7 is 28. So perfect. You didn't have to worry about the mental math. You can actually just do that in your calculator. And then x squared divided by x is just x. And the way we do that is either thinking about exponent laws and thinking, okay, when I have the same base, I'm subtracting my exponents, and technically there's an invisible 1 there. Or for this one, you can just think x times what will give me x squared. Well, I just have to add on another x. For the next one, 4x times something should give me 8x. Now for this one, it might be a little easier. You might know 4 times 2 is 8. So you can just put plus 2, and then we don't have to worry about the x because the x's match. Or you can continue with that division idea and see 8 divided by 4 is 2. X divided by x, well, they just cancel each other out because anything divided by itself is just 1. So the x kind of just disappears here. Okay, in the next one, we have 3 terms here. So 20a cubed minus 15a squared plus 25a equals 5a times something. So first of all, I should have 3 terms here because I started with 3 terms. And in the first one, 5a times something should give me 20a cubed. So if we're using the division idea, I'm going to divide 20a cubed divided by 5a. So 20 divided by 5 is 4. And then for the a's, I have 3 a's on top, only 1 on the bottom. So when I divide them, that's 2 that are left. You can also think of it as a times a squared should give you a cubed. Okay, for the next one, I'll just do the division method again. So negative 15 divided by 5 is negative 3. And then a squared divided by a. I have 2 a's on top, 1 on the bottom, so there's only 1 left over when I subtract. And then finally, 25a divided by 5a. The a's cancel out, but 25 divided by 5 is positive 5. And there we have it. So in this warm-up, I gave you half of the puzzle. I gave you either the single term out in front, or I gave you the bracket. Now let's do a full example here. So if you look at the next ones on the page, you will notice that there's just a starting expression and we have to factor it. Now, this idea of having a single term out in front and then this bracket, this is called a greatest common factor. So the term that you see out in front over here, that is called your greatest common factor. Now, to get the bracket, we kind of saw what we had to do. We had to use the opposite of multiplication, use division, or a kind of guess and check type of thing. But to get this GCF, this greatest common factor, it kind of relies on our multiplication knowledge a little bit. So let's look at the coefficients. 4 is the biggest number that both 8 and 4 are divisible by. 2 is the biggest number that 6 and 4 are divisible by. 4 is the greatest number that 28 and 8 are divisible by, and 5 is the greatest number that all 3 of these are divisible by. So your greatest common factor is going to be the biggest number that all your coefficients can be divided by. And then in terms of the variable, you will notice that the variable that we have in each case is the variable with the lowest exponent. Notice in this first example, we had x squared and x, but we were only able to take out an x because that's all that was common to both terms. This term had 2 x's, this term only had 1 x, so we can only remove 1 from each because that's all that was common to both. So let's try some examples here. And I have the steps listed out. So the first step is to find that GCF. Now, you're going to first check your coefficient and see what number they have in common that they are both divisible by. So if I look at 9 and 6, 9 and 6 are both divisible by 3 because I know 9 divided by 3 is 3 and 6 divided by 3 is 2. Now you might have asked, why is it 3? Well, if I try 2, 9 divided by 2 gives me a decimal. That wouldn't work. If I try 4, both of these would give me decimals, so that's not good. You're trying to find the number that both terms can be divided by to get a nice whole number. So 3 wins here. And then in terms of the variable, the first term has an x, the second term has no variable, which means x is not common to both. So our greatest common factor is just a 3. Sometimes there's no exponent, that's okay. So all we're going to do is write an equal sign, put the greatest common factor out in front, and then open up a bracket. Because we started with 2 terms, we should know that our bracket will have 2 terms. And again, there are 2 ways you can do this. The first way that requires less guess and check, I would say, is just showing it as division. So 9x divided by 3, well, that's just 3x. And 6 divided by 3 is positive 2. So here we are. And if I were to check this, 3 times 3x gives me the 9x, and 3 times 2 gives me the 6. Okay, so you can use that division idea. You could have also just asked yourself, 3 times what gives me 9x? And if you have a good grasp on your multiplication table, then you can say 3x right away. 3 times what gives me 6? 2, and so on. Okay, let's try the next one. We have 15x squared plus 10x. So first I'm going to look at the 15 and the 10. Both of these numbers are divisible by 5. And again, if you struggle with your multiplication table and you can't see that number right away, you would kind of have to take your coefficients and ask yourself, what numbers are they divisible by? So for example, if I take 15, I can divide 15 by 1. I can't divide it by 2, 3, 4, because if I try that in my calculator, I'll get a decimal. It is divisible by 5 as well. 6, 7, 8, 9, even 10, I can't. So really the next one is 15. Those are the three factors of 15. For 10, 10 can be divided by 1. It can be divided by 2. It can't be divided by 3 or 4 because then you get a decimal. It can be divided by 5, 6, 7, 8, 9 doesn't work, and 10 does. So if you create this list of common or factors of each number, let's see what they have in common. They have a 1 in common, but they also have a 5, and that's the greatest factor that is common to both. So this is a bit of a longer way to do this, but if you struggle with your multiplication table, it might be helpful to write out those factors and then see which one's the biggest number that they have in common. Okay, so that's the coefficient. And then in terms of the variable, I see an x squared and I see an x. So they definitely both have an x in common. This one is x squared, this one is just x. We always take the lowest exponent, and it's just an x here. Okay, and now we open up our bracket. We can show our division here to take away the guesswork. 15 divided by 5 is 3, and then x squared divided by x, I have two x's on top, and I'm taking 1 from the bottom, so I have 1 left. 10 divided by 5 is 2, positive 2, and then the x's just cancel out. I don't have any more. So there we are. Okay, let's try another one. 6x squared minus 4x plus 8. So 6, 4, and 8. The only number that they have in common would be 2. Okay, because if you look at 4 and 8, you might say, well, they're both divisible by 4. But 6 isn't divisible by 4. So it has to be something else. And 2 would win here. If I look at my variables, I see an x squared, I see an x, but then the last term doesn't have an x. They don't all have an x in common, so it can't be part of the GCF. So I'm going to write my equal sign, the 2, open up a bracket, and if we want to take the guesswork out, I'm just going to show it as division. So 6 divided by 2 is 3, and what's nice about not having a variable in your GCF is that you don't have to worry about the variable at all. You just stick it on. So then negative 4 divided by 2 is negative 2. Stick the x on. 8 divided by 2 is 4. And there we are. Okay, the next one. 14m squared minus 21m plus 7. 14, 21, and 7. If you look at a multiplication table, all three of those numbers are part of the 7 column or row. So 7 is your GCF. And then m squared, m, nothing. So there is no common variable here. Make sure you write your greatest common factor out in front, and then we can show our division. 14 divided by 7 is 2, then the m squared stays. Negative 21 divided by 7 is negative 3, and the m stays. And 7 divided by 7, it doesn't disappear, but anything divided by itself is 1. All right. E, 2k squared minus 7k. So if you look at 2 and 7, they have nothing in common. 2 can only be divided by 1 and 2. 7 can only be divided by 1 and 7. So technically they have 1 in common, but when you divide anything by 1, you get itself, so it doesn't do anything. So in terms of the coefficient, nothing really. But then I have k squared and k. So in this scenario, they actually both have a k in common, and just 1 because that's the lowest exponent. If you wanted to, you could write that as 1k if that helped. So I'm just going to write the k and then divide everything by k. Technically it is 1k, so the coefficients stay the same, but k squared divided by k, I'm just removing a k, so that's just 1, and then minus 7, k divided by k, they cancel out. And here you have it. Okay, for f, 2v squared plus 14v minus 10. I want you to pause the video here and try to identify the GCF on your own. If you feel confident with your GCF, actually do the factoring. If you don't, come back to the video just to see if your greatest common factor was correct. All right, so 2, 14, and 10, they all have a 2 in common. Nothing more than that, because if you try to divide 2 by anything more than 2, you're gonna get a decimal for sure. And then v squared, v, nothing, so it's just 2. So I'm just gonna divide all 3 terms by 2. I'm gonna open up my bracket. 2 divided by 2 is 1, and then v squared. You could also just write this as v squared, which is what I probably would do. 14 divided by 2 is 7, and then the v stays. And negative 10 divided by 2 is negative 5. And there it is. Okay, for the next one, 12a to the power of 4 subtract 6a squared. Again, I want you to pause the video, write your greatest common factor, but then come back to make sure you got it correctly, just because the exponents are a little higher than normal. All right, so between 12 and 6, they're both divisible by 6. Now, technically, they are also both divisible by 2 and by 3, but this is called a greatest common factor, so you have to take the greatest number they have in common. If you wrote 2 and 3, it's not that you would necessarily be wrong, but you would not have fully factored. And then in terms of your variables, we have a to the power of 4 and a to the power of 2. So the first term has 4 a's, the second term has 2 a's. We take out the lowest number, which is a squared. Okay, that's what they have in common. Anything more is too much, because a squared, you can't remove more than you have. And if you took too little, then again, you're not taking what they have the most in common. All right, so I'm gonna write my GCF out in front. I'm gonna divide my first term by 6a squared. So 12 divided by 6 is 2. A to the 4 divided by a squared. I have 4 a's on top, and I'm removing 2, so I have 2 left. And then for the next one, 6 divided by 6 is 1, well, negative 1. And then the a squares cancel out, and there we have it. All right, H. Pause this video, try to find your greatest common factor, and try to factor it, or come back to the video to check your work. 20 and 16. Now, they are both divisible by 2, but they're also both divisible by 4, and that is as high as you can go. If you said 8, 20 can't be divided by 8, so that wouldn't work. And then in terms of the variables, we have an x squared and an x. Just a single x is the common variable. So I write my GCF out in front, and I'm just going to divide both of these terms by 4x, just to take the guessing out of anything. 20 divided by 4 is 5. X squared divided by x is a single x. Negative 16 divided by 4 is negative 4, and the x's cancel out. And again, if you're ever unsure of if you did it correctly, just try redistributing that greatest common factor in to make sure you get your original expression. So 4x times 5x gives me 20x squared. 4x times negative 4 gives me negative 16x, so I know I did it correctly. Okay, for I, again, pause the video, try it out, then come back to check your work. 12 and 8 are both divisible by 4, and that's it. They do not have a common variable because the first one has an x, but the second one does not. Now for communication, please make sure you start each line with an equal sign. 12 divided by 4 is 3, and the x just stays. Negative 8 divided by 4 is negative 2, and that's it. J has, again, more exponents, slightly bigger numbers, so try it out, pause the video, then come back to check your work. Okay, so looking at this, 16, 24, and 8. First of all, the fact that 8 is our lowest coefficient, the greatest common factor has to be 8 or less. And you know what? 8 might work. 16 divided by 8 is 2. 24 divided by 8 is 3. They're all whole numbers, so that's perfect. If you had said 4, which is also a common factor to all of them, It is a common factor, but it's not the greatest. In terms of your variables, we have x to the 4, x to the 3, and x to the 2. 2 is the smallest, so I can take out 8x squared. So I'm going to write my 8x squared out in front. I'm going to open up a bracket, and I'm just going to divide each of these by 8x squared. So 16 divided by 8 is 2. X to the 4 divided by x squared. 4x is on top and I'm removing 2. I have 2 left. Negative 24 divided by 8 is negative 3. And then I have 3x's on top and I'm removing 1. So that's just x. 8 divided by 8 is 1. X squared divided by x squared, I have 0 x's left. So no point writing them. All right, 2 more. For k, the numbers are quite larger. So again, pause the video, and if the numbers are larger and you want to write out those common factors, go ahead and try that. Then come back to the video to check your work. All right, so between 8 and 27, 27 is actually a common factor because 81 divided by 27 is 3. So I know the numbers are larger, but that was the first thing I tried. I tried 81 divided by 27 to see if that works, or else it would have to be something less, like potentially 9. So just a hint or something to keep in mind, your greatest common factor is either the smallest coefficient or less. So the smallest coefficient here was 27, so it had to be either 27 or something less than it. The greatest common factor will never be something larger than your smallest exponent or your smallest coefficient. Okay, then between x squared and x, they both have an x in common. Okay, so let's divide. Like I said, 81 divided by 27 is 3, and then 27, or x squared divided by x is x, and then 27 divided by 27 is 1, or negative 1, and then the x's cancel out. So there you have it. Okay, last one. The last one I added a tiny little twist, which is our first term is negative. Now I made a little note at the very top here, which is if the first term is negative, you have to factor out the negative. So that means in this scenario, because my first term is negative, my GCF will be negative something. I don't know what it is, but it has to be negative. Okay? Now, let's look at 24 and 6. They're actually both divisible by 6, so I'm going to add that on. And then between x cubed and x squared is the smallest exponent. So negative 6x squared. Normally, you would probably just say 6x squared, but again, because the first term is negative, you have to remove the negative. It is just a proper communication thing. Because when you write your bracket, you want the first term to be positive, so the negative has to be removed. So I'm going to write equals negative 6x, open up the bracket, and now when we divide, we're going to have to be very careful with our signs. So negative 24 divided by negative 6 is positive 4. Perfect. You never want your bracket to start with a negative. And then x cubed divided by x squared is x. And then positive 6 divided by negative 6 is negative 1. X squared divided by x squared, well, there's 0 x's left, so that's it. All right, so that's your greatest common factor. So once again, to find your GCF, you're going to look at your coefficients to see the highest number that your terms are divisible by. If all of your terms have a variable in common, you're taking the smallest exponent. And then to get the leftover bracket, you're just using some division because the opposite of multiplication is division. So that's a way for you to better get the brackets instead of doing some guess and check or relying fully on your multiplication table. Although if you're good with your multiplication table, you don't have to do division, although it is a more safe way to go to ensure you're on the right track. And that's it.